In this question, we know that they are three identical rocks, so the masses are the same, but again, that shouldn't matter for a projectile. They're all launched from the same height, HO, different directions. We want to relate the magnitude of the vertical component of the velocity immediately before it hits the ground. Immediately before it hits the ground. So let's consider rock 3. Rock 3 is going to have a vertical component. Its instantaneous velocity is 0 in the vertical. And it's going to increase by 10 meters per second every second. So that's rock 3. In terms of the velocity, it's a pretty straightforward understanding. Now, if we look at 45, and let's just say that it has an initial velocity of its vertical component. It's VZ. Let's say it's 20 meters per second. Well, then if we look at the time, 0, 1, 2, 3, 4, like so, its velocity is initially 20, then 10, then 0, then minus 10, then minus 20. And then after 5 seconds, it's minus 30. And it's at this 4 seconds that it is returned to exactly the same height. 2 seconds up, 2 seconds down, plus 20, minus 20. Now, if you notice then, if you look at R2, since it's 45 degrees, if its vertical component, if R1's is 20 meters per second, then R2's will be minus 20 meters per second. So its velocity is minus 20, minus 30, minus 40. So at the instant we reach 4 seconds, it's the same as this. So the motion, if we look at just R1 from this location downward, is exactly the same as the motion downward for rock 2. All there is this additional time it takes to come up and get back to the original height. But once it returns to that height, they both have an initial velocity of minus 20 meters per second. So that means the behavior here in terms of the velocity from then on will be exactly the same. So we are looking for an answer that says 1 and 2 are equal to each other. So that takes those two out. And the question is it also equal to 3? And if you look at R3, no, the vertical velocities will not be the same. These two have a greater initial velocity, so the length of time it takes to get to the bottom, and therefore the average velocities will not be the same. So therefore, we are looking at choice 1. And these velocities will be greater than the velocity at 3. 4, 3.